Hello and welcome back. And my name's Corey, and I guess you're my rubber ducks for the afternoon. And this is a series where we are creating a programming language from scratch using C++, Bison, Flex, and all sorts of other stuff. Well, today we're going to focus on how we can turn our project that we've been creating into a shared library. And I'm going to work on compiling it as a shared library that we can then use proper soname conventions and such as that and install it in an Ubuntu system. And I'm jumping just right in. It's been a couple weeks since I've recorded a video just because, well, I slowed down. I was putting out one video a day, and that's a lot of work for the length of videos that we do. But then I came upon this, and I knew I needed to do this. This is that kind of a housekeeping thing. And that is this turning it into a shared library. And it took me down a path of, because I didn't know how this worked off the top of my head. I had to look it up, and it's not something that you learn in classes usually because it's specific to one operating system, not a general operating system concept. That is all the details of this. So it took a while for me to research it. As always, this is 100% live coding. I don't have this pre-planned. I do have notes where I've done this on a similar project, but it's different for this one. So the goal of this has been showing you what happens when you try to program. So that's where we're going to go from. And where we are is where we always start, and that is we are in our repository. And if I say get status, you'll see that there's no changes. Get log, the very last thing that we did was episode 101. This is episode 102. And so let's see, on the right hand side, what I normally do is make clean and make tests, and we're just going to compile this, and I will show you what happened, what got my attention when I realized that there was a slight problem with the way I was doing this originally. And so it's I'm only using one thread to compile, one process to compile. I probably should have thrown some more threads at it. But what we're going to see is that at the end, of course, what are we doing? We're compiling a bunch of object files. So we've got all these CPP files everywhere, and we're compiling them into object files, and then we're combining all those object files into a shared object file. We already do that. And in fact, on the left-hand side, I'll pull up the make file. And I think if I look for target, there we go. This is where we compile the thing. Whatever compiler we're using, in this case G++, whatever our flags are, and we add this -shared, and to tell it, hey, we're compiling a shared object, and the output is the $add, of course, means this part right here, the directory and the target, and then I say and include whatever was in all the dependencies, that's all the object files, and then whatever linker flags I need. And okay, so we've got this here. All of our tests have passed. That's always a good thing. And you do notice that it says could not load library at path lib does not exist .so. That was one of the most recent things that we added. That is supposed to be there. Okay, so don't be thinking that, oh no, it's doing something that it shouldn't. No, we're okay with this. It's supposed to be giving us that error. And what's kind of interesting is, so we can also see right here, and I'm hoping, I need to make sure that I'm not in the way. It's kind of small right here. You'll see the path that's run when this is executed. So I'm calling /, gotta click over there, /build apps test. If I don't give it the gtest brief flag, it will give me the expanded output for each one, but it runs just fine. But there's something weird that happens. If I go into build apps and now list all the files here, and okay, they're slightly out of the way. But of course, libtang is the name of this library that we are that we're trying to run, or that we created. And then tests is the name of the program that we're running. So we're running the test program, and it loads this libtang.so, that shared object library. Yeah, so it runs that, and it'll load this libtest library and other things as well. But all of these files, the Tang program, the test program, and test Unicode, they can all be run from this directory. So if I run test Unicode string, runs just fine. If I run test, I get an error. And the error is, I'll scroll it up so that you can see it. The error is, error while loading shared libraries, libtang.so, cannot open the shared object file. No such file or directory. It can't find it. Now, if this were Windows, the fact that the executable test is in the same directory as the executable libtang.so, it would be able to find it just fine. It can't. So, why not? Why did it work earlier? Well, there's a couple of reasons, and I've got to go to my notes so I can remember the commands. But there's a command called LDD, and we can give it test, and what it will do is it will tell us for the linker where all it's finding libraries. So these are all the libraries that get loaded: Linux-VDSO, and libstandard C++, and libtang. And notice it says not found. All the others, it's finding them somewhere, lib whatever. Okay, so if I go back to my main where it does work and run LDD and give it build apps test, notice libtang is found, and it finds other things. Why? Because libtang includes other things like the ICU stuff and all that. So once it finds libtang, then it can load other libraries as well. But getting back to the point though, it found it in build apps libtang. So for some reason, it's like looking in a particular place. Well, we can, let's see, can I do this? I've got to find the command. I think if I type in readelf-d, I hope this is right, build apps not libtang, test. There we go. Yes, here's why. Because it says, hey, these are the libraries that I need, and there's libtang, and it's just given the name. But we provided a run path. We said, here's where it is. Here's where to look for these libraries if it's not in the default location. So we hard-coded it. And that was to get it running and everything. Well, this we don't want. We don't want to hard-code in a run path. Yeah, so let's see where that happens. Again, I'm in my make file. I'm going to go to the top of the make file, and when we is it after this or so Tang library, this is what we include. Tang library, we include that variable when we're compiling tests and all these others, and it says -L where to look for our compiled stuff. Yes, but it has this -W L and then dash capital W L again, and the comma just means that pass this to the linker. So after the compilation step, the compiler takes care of this for us because we're doing it all in. It just does it. It compiles and then it links for us. So this is what we're passing to the linker, and we're telling the linker, the dash R means set a run path. And what are we setting the run path to? That's the next one, the appdir, and that is ./build/apps. And that was just to get this running. That's a problem. Can we work around it? Yes. So I'm going to, right now I'm just trying to explain the problem that we're trying to solve. If I go back into build apps, and if I try to run tests, we know it's not going to work. However, I can set an environmental variable, env, and it's ld library path, and just the current directory. And say, basically I'm saying, look here when you're looking for the libraries as well, right? So, and now if I run test, I'll see it runs. It loads. Now, there is one failing test, but it's because I hard-coded in load a library at ./build apps test library. But it doesn't matter. It doesn't matter. That's okay. We can deal with this. The point is that if we use that environment and set it just, and why do you put it here? So that it only runs, it's only set for this one execution, this one command that you're running, and then it goes back. So if I were to echo, is it $? I think so, yeah, it's empty. Because by default it's empty. If I had put, set ld library path is equal to period in my bash rc file, for example, then it would be that way. It would be set for the entire time I'm running this, and it would just work, but it would only work for me, and that's not really the right way to fix this. So, okay, so let's go back. Now, where are we? We are in the build directory. And remember the command we said ldd and Tang, not Tang, test. And it said, hey, I can't find this libtang wherever it is. If I do the same environmental variable, ld, not load, is it load? Library, ld library path is equal to period, and now run the LDD. So I set the library path just temporarily to the current one, and now ran LDD, and this says, okay, linker, tell me where everything is. You notice it found libtang locally. That's important. Okay, so can we fix this? Can we make our compiling happen a little better? Notice other things. Do you see how there's all of these, like lib ICU UC? So this is the ICU library, and I don't remember what UC is for. Probably Unicode something. But anyway, it's .so, that's .shared object, then .70. Whereas libc.so.6 or vdso.so.1. What on earth is that? That is a major version number. So yeah, libicu is up to version 70. Well, I think it's actually on version 72, but version 70 is what is installed on this machine. And you see where it says that it found it, lib x86, 64, Linux, GNU. If on the left-hand side, I'm just going to list everything in the /lib x86. Sure, there we go. You see that there are a lot of libraries, and just choosing one at random, libxtables, whatever it is, .so.12, it's actually a symlink to libxtables.so.12.4.0. So this is a major version number, minor version number, and then a patch number. And if we scroll through here, you'll see OpenSSL right there is on major version 1, minor version 2, and patch number 33. And I mean, it's just, they all follow this convention. And there's a symlink. So the thing is if I had asked for, well, I'm trying to find one that's really obvious, but I don't know if there's one. There's so many libraries here. One of the Qt libraries, Qt libraries, or libpython. Sure, why not? libpython 3.10. .so, it's actually going to point to libpython 3.10.so.1. But libpython 3.10.so.1 actually points to libpython 3.10.so.1.0. So, yeah, that's the whole point is that there's usually a general name, and it will point to like the most recent version. And that's what the kind of structure that we want. But also, there's one final piece of the puzzle. And that is, again, I'm going to open up my makefile here. And you'll notice, for example, when I want to include, on this line here, the ICU library, there's this command that's being run, pkg-config. I run it on the right hand side, pkg-config libs C flags, and let's just choose one, ICU-IO. If I run it, notice it actually includes the library things that should be included. So this is like telling me what needs to go into the compile thing, into the compile string. So if we really want our project, our library, to act like a library that everyone else uses, we need to provide this functionality, this this package-config, and to give it libtang or whatever, and it use that name. And it provide the right flags. We're going to do all of that today. Okay? So, we're going to make our library use the right names with versioning. We're going to make it so that when we compile our functions, they can, or our programs, that they can find the library. So we're going to do the install stuff. And then we're going to make it so that we can install our header files and our shared object library, so it can be used globally. That's a tall order, and trust me, it took me hours to figure out a way to do it. I'm not even going to say this is the best way. This is a way of doing it, and it's how I've been able to figure it out. All right? One other wrinkle to throw in here. This project is bigger than I've been showing on this channel. You say, Corey, this is episode 102. I know this has only been about the programming language, but I have a few other projects that I'm working on under the name. If you've noticed, the GitHub repo is under the name GHOTI. I'll spell that for you. GHOTI.io. It's pronounced fish.io. And if you don't believe me, there is look up the Wikipedia page for the word GHOTI. It's not pronounced goatee. It's pronounced fish. And it's a joke about the English language. There's a lot of reasons that I chose it. First of all, I think it's funny. But also I/O, normally we think of it as input-output but I believe it's actually the top level domain for the Indian Ocean. So it's fish.indianocean. Anyway, and then Tang, it's the name of this language, template language. That's what it stands for. But it's also a type of fish. So, but anyway, there's several different projects that I'm working on, and they're all going to be under the name of fish.io. And just like there's a Boost library, I want this to sort of be like the fish.io library, and it's the things that I want to build. And so we've got to include that structure, and we're going to start that with this here. So, all right, what do I need to do now? I'm glad you asked. First of all, what do I want my library to look like? What name? Let's choose that. And I'm going to do that. Well, you can see on my left-hand side, I'm just going to type out the name I want to use. So fish.io, Godey.io, whatever, -tang. That's the name of this library. Why? Because there will be others. .io-pool is a worker pool, thread queue type thing. I've got one called Wave as well that I'm working on. But anyway, this is the first one. But libraries normally, or Linux expects them to start with the word lib and to end with .so. And then we've got the major, minor, and patch. And I'm just going to start off with so.0.0.0.0. And that is the full name that I want to use. Okay? So libfish.io-tang. Okay? So how do we do this? First of all, I think I'm going to... Let's do my base name as, because I'm going to use this in several different places, might as well use variables, and we'll call it libfish.io-tang.so. Okay. The major version is going to be a 0, and then the minor version will be 0.0. These are strings. And then there's something called an SO name. Remember how I said that, well, we can still see it on the right. So there's libm, the math library, right? That is SO.6. But that's probably not the one. It's probably 6.something.something. But we just link to the kind of like main version that we want. Excuse me, sorry, had to yawn. This is called the SO name, shared object name. And we need to be able to get that. So our SO name is going to be our base name dot major version. There we go. And then let's see. Our target now is no longer going to be libtang, but it's going to be our SO name dot minor version. All right? I think that's pretty good. So I don't need this up here. But now I've got these things. I've got my base name there, just to kind of put this all together. And so when I increment the minor version or the major version or whatever, we can do that. All right, so double check my notes and see, did I forget anything? I hope not. Did I forget anything in my flags? No. Okay. Now, for the Tang library. We're going to get rid of these linker directives. I think I can do that, yes. And then I don't want the colon. The colon says look for an exact name. I want it to use an SO name. And so I just need that. And I don't include the lib. It's just godie.io-pool. And it should find the most recent. Yeah. All right. Now, when I'm compiling the target, okay. There we go. When I'm compiling the target, this is the compile string that we use. And notice we've got this dash shared. That tells it that we're making a shared library. But we need to pass, nope, there we go. So dash WL is pass something to the linker, and then you do a comma, and then I can give it either as, well, I want it to pass dash soname, and then I could do another dash L comma, and then give it the, soname. There we go. But I could also just separate them by commas. So I'll do that. So now when we compile our target, we're telling it use that soname. Okay, I think that's good. Now, of course, our... You know what? Let's just go for this. Let's see. I don't think it's going to work yet. But let's... I need to hit save. There we go. So make clean. Oh, because I'm in a sub thing. There we go. Make clean. It's going to do... Okay. Now make... I'm going to say make test-J8. Throw 8 cores at it. It's normally I don't do that, but this is just for the sake of time. So what I'm expecting is for it to compile a shared object library. I'm expecting for the compiling of the test to work, but I'm expecting for the execution of the test to fail. That's what I'm expecting. And let's see what failed. If I say just make test by itself, so it's trying to compile it, but it can't find the fish.io dash... Oh, I said dash pool. Why did I say dash pool? Because that's the name of one of my other projects. Where do I have pool? There we go. It needs to be dash Tang. Do I have pool anywhere else in here? No, I don't. Okay, let's try that again. Does it compile? Hopefully. No, it's not finding it. Why is it not finding it? Go back to my notes. Do I have a note on this? Oh, I think I know why. But, and I don't have a note on it, I'm going to now go to build/apps, and we'll see that it did create, and that's behind my head, I think. Yes, it did create this libfish.io-tang. It did create that. And it did create this test library and test Unicode string. But it's not finding this because I'm asking for, we can see here, -l build app. So I'm telling it where to find the library, and I'm asking for the library of fish.io-tang. But that doesn't appear in this directory. I only have libfish.io-tang.so blah blah blah. Okay, I've only got that. So how does it use the soname? Now, what was the other thing to show the soname? It was readelf-d. Readelf-d, and if I say libfish, and we'll see here that, so this is my, I'm reading the library libfish.io-tang, and we'll see it did set a soname of libfish.io-tang.so.0. That's the major version. Okay, that's what I want. But what I need is I need symlinks to point to this. So we're going to add that. So where does it go? In the yes, when I'm building the shared library, I missed something. So let me look for target again. Here we go. So this is after creating the shared library, I need to add some symlinks. So when you put the @ sign, that means don't show the actual command, just do it. And I'm going to link -f means don't complain if it already exists. -s means it's symbolic, and where's it going to point to? It's going to point to the target. And where am I creating it? It's appdir/soname. That's right. And now I need one more. -f-s, and what is this going to link to? This is going to link to the soname and appdir/ base name. Yeah. All right. Now, in order for this to work, I may have to libfish. There we go. Just remove that file so that make will make it. We'll remake it. And oh, look, we made the shared library, and it already went through the test has obviously worked, and then compiling that one worked. Which one would the string test pass, but then the normal test does not. It says it can't open this oh, and that's behind my head, isn't it? It can't open libfish.io-tang. It says it doesn't know where to find it. Good. We can do this now. So I'm going to go back into build apps, and you can see here, I know that keeps going behind my head. This is the pattern that you want to see in Linux. You've got your SO name, or your regular name, your base name pointing to your SO name, and then your SO name points to your full version name. And that's my full version name, the one that we just compiled. That's what we want. And notice by providing those two symlinks, it was able to compile all of the tests. It just couldn't execute it. So if I look at LDD test, right? This is saying, show me where all of the directories are, or excuse me, where all the libraries are. And it's saying, hey, I'm looking for libfish.io-tang, but I can't find it. But we already know that if I set the environmental variable of ld, what is it? Library path is equal to period, and then run test, it will run. Ignore the fact that this one, because it has a hard-coded path, that it failed. But we know that that will happen, and if I run LDD test, we'll see that, yep, it was able to find my test. I mean, it was able to find my library when it was trying to execute the tests. So what we need to do then is add this environment to the pointing to the proper place when it tries to run the tests. So to do that, we come over to where we're running the tests, and that's going to be right over here, the test library, test Unicode string, test. Here we go. Now that's to compile it. What about running it? Oh, right here. It's the test target. So it will compile everything, and then it tries to run, it runs a Unicode string, which that doesn't need any special library, so we're good there. And then the test program itself. And all that we need to do is to say environment of, what's the name of it? LD library path is equal to something. And what is the something? In this case, it's the app directory, because we're running it back in the kind of parent directory. So we're saying, if we're telling it, hey, I promise, if you look in the app directory when you're running this test, you'll find what you're looking for. That's what we're telling our makefile, or that's what the makefile is telling the program. So let's try it. I'm backing up. I'm in my main directory, and if I say make test, everything runs. That is good. Okay, so the string tests weren't looking for the library, but everything else is looking for libtang. Again, ignore the fact that it can't find lib does not exist, because it's not supposed to. That's the point of that particular test. So, but all the tests are passing. That's what we wanted. Okay, so back up. What have we done? We've seen that when we compile our library, I'm getting there. Here, when we compile our library, we can add we can pass to the linker the fact that we want a specific soname, okay? And that's kind of like the middle name, the one that has the major version attached. Then we know that we need to create symlinks of the kind of generic name to the to the target, and then the base name to the soname. Excuse me, I said it right. The kind of generic name to target, and it's just easiest to say if I say list build apps. There. We link the generic name fish.so to the one with the soname. Yep. And then the soname to the one with the major, minor, and patch number. And then, of course, we create the major, minor, patch. That's what we want. Okay. That's good. Now, the last thing that we changed, and again, I'm just trying to recap it so that I kind of keep it all straight in my head, is when we are compiling, we no longer want to, it's down here, pass all of the other stuff. We just want to give it the base name, fish.io-tang. And remember, Linux will then add the lib to the front and put .so at the back. And because we say, hey, right here, libfish.io tang.so points to this one, and that one points to this one, it compiles against the correct library. So before, also remember we had a colon. If I said compile it with an -l colon, it wouldn't look for the SO name, the SO name at all. It would look for this exact name, and we don't want that behavior either. So those are the changes that we had to make. Now, get status, get diff. I'm going to make sure that it has just the changes I want. Yep. I'm no longer calling it libtang, but we're calling it this fish.io-tang, and that's fine. We changed what we're giving to everyone. And by the way, we're probably going to even change this in just a moment, but for right now, it's working. And then when we're compiling the shared library, we added the soname directive for the linker. We created the two symlinks. And then when we executed the test, we had to tell it, hey, here's where you find it. And this is only, again, after the next step, we won't have to do, well, we'll leave that there. I'll explain it. But that's not the end result. This is just getting it so that our program, our project still compiles and everything works. That's the goal. All right. So get add makefile, and I'm going to say get commit, and what's the commit message going to be? We're going to say change library so that it uses proper a proper soname. Yeah, that works. All right, so the next step is we need for this to be installed globally. I want to be able to type make install, and it installs the library. Okay, so let's do this, shall we? So makefile, in order to do it, I'm at the bottom. I've got all of these here. So remember, .phony is saying, hey, these aren't actually files, these are commands. And one of them is, try to go in alphabetical order. There's a new one going to be called install. And where am I going to put this? I'll put it after the test clean. Let's put it here. Install. And if I do the double pound, then when I say over here, if I say make help, it will, give me a list of all of the commands that you can say: make clean, make all, make test watch. We do that a lot. And this is an install. You're going to have to run it as sudo because you're installing it in your system. But yes. Globally requires sudo. Sure, why not? What do we need? So if I put something here, install the shared library. I know that that's a thing that's going to need to do. I know we're going to need to install the headers. Oh, that's going to be a mess. That may have to be a separate one just to get it working. But okay, we'll go with this for right now. Install the pkg-config files. Yeah. Oh, and I'm going to need to do this. Run ld config. And then the last thing is I'll echo. Remember the @ sign just means don't actually show it, just do it. And this is going to be Tang installed. Now, if I, on the right-hand side, now just say, well, first of all, make help, and you'll see that it does have install. But if I say make install, you notice it passes these through. I mean, to the command line, but the command line treats the pound as a comment, so it just kind of prints it out. I'm okay with that instead of an echo. Somebody can correct me if that's bad form, but that's what I'm doing right now. So install the shared library. Where do we put this? Well, first of all, what I wanted to show first is this. There's an LD config, and I've got where are my notes so that I can see. So all the libraries that the system knows about, if I say -p, it tells me, yeah, these are all of the files that I know about. So if you ask for lib, bd, crypto, whatever, this is where it's actually installed. Lib, x86, 64, Linux, blah, blah, blah. Oh, here's libboost. There's a lot of libboost stuff. So the boost library already installed. I think if I grep for, does gtest have one? No, it doesn't. But if I look for ICU, we'll see all of their libraries that they ship with. And you see that, oh, they do have a generic name that points to kind of the generic library. And then specifically .70, which points to that, yeah. So these are the SO names, right? Anyway, all right. So we want to do that, but we don't want to install in lib x86 64. It's just I'm not comfortable installing there. I mean, I could, but I would rather install it in one of the user directories. And so I'm going to make a directory, and I don't think it exists yet. So in fact, yeah, so there's a user local and user local lib and user local include. So the lib is where we're going to put our shared object stuff, and the include is where we're going to put our .hpp files, our header files. So if I look in lib, I could just dump them in directly, but since I know that I'm going to be creating a lot more, not just Tang, but also you've seen the name pool, Wave is one. There quite a few things planned. I'm taking this pun to the max. I want them all together, so we're going to make a directory here. So you know, let's just start here. So for the shared library, I need to do a make dir -p. -p will make all the parent directories, and it won't give me an error if it already exists. And user lib local user, is that where I am? Yeah, user local /lib /fish.io. Yeah, that's good. And now I can copy my appdir /target to user local lib fish.io. Okay. And then I can link. Now, because we may run this multiple times, I don't want it to give me an error. So I'm saying force it. And -s is symbolic. And, oh, what is it? target. We already did this earlier, but that's okay. User local lib fish.io / and then a soname. The soname. There we go. And another one. This is the soname user local lib fish.io, and then what is this? Base name. And this I'm following my notes because I don't want to have to think through it, but this is what we did earlier. And then, is there anything else? Well, let me go ahead and do this. Okay, so I've done it. Get back to there. If I say make install, it's going to give me an error because it says, hey, I can't do this. You have to run it as sudo. There's my password. Did you get it? So it told me that it did this stuff. Obviously, we know we've only done the shared library. And it says that it's installed, but that's because it's just text. If I now try to run / what is it called? Build apps test. It's still going to say, hey, I can't find it. Well, remember there's ld config-p, right? That lists everything. And if I search for fish, it doesn't find anything. The reason is because you have to actually just run ld-config as is. So I'm going to add to my makefile ld-config. That's all I need to do. So now let's make install again. This is an error, and this is because it's from the WSL, Windows Subsystem for Linux. It has nothing to do with our program, and just ignore it. Yeah, just ignore it for right now. But now, if I do the ld-config-p and grep for fish, oh, it did not find it. Did I not put it in the right place? Did I miss something? Oh! Yeah, I'm sorry, there's one other thing. So we're putting things in user, in here on the left, user local lib fish, but Linux doesn't know that it needs to look there yet. So there is, where is this? It's so on the right hand side, I'm going to go to /etc/ld.so-conf-d, and this is what it is. I'll scroll up so you can see it easier, up above my head now. The LD is the linker, right? The loader, whatever. Dot shared object configuration, and I guess this is the directory, whatever. And what it looks at all the files. So these are all the files in that directory, and all that these contain are, if I'm going to cat one here. So cat libc.conf, and you'll see it has a comment, and it just says, hey, user local lib. There are shared objects in user local lib. And all of these, the main thing that it contains is it's a file that might have a comment. Who cares if there's a comment? But it tells Linux where to look for shared files. So we need to create one of these files. Simple, simple, simple to do. So all that we have to do is, again, I'm just adding it so it doesn't show what we're doing, but we're going to echo, and all that I need is /user /local /lib /fish.io. Do I need, I don't think I need a closing. There we go. And I'm just going to put this in etc /ld.so.conf.d/ and call it my name. So we will say fish.io-tang.conf. Yeah. And now, try this one more time. Go back to fish, tang, sudo make install. There we go. Now, if I ld-config-p and search for my library, look, we see both of them. We see my basic name that points to my, or it says it is here, and for the major version 0, notice they both point to the correct place. And once they get there, then they follow the symlink. So this is fine. This is what we want. Yeah. So that's good. Now, if I go back and run build apps test, build apps test, I just ran it and it was able to find it. It was able to run it because why? If I say ldd build apps test, it says, yes, I was able to find the shared library. Notice it, even though when we compiled it, I don't think I'm seeing it over here, but when we compiled it, we just gave it fish.io-tang. It added everything else, and it said, oh, well, the soname for that is the .0, so that's one we're going to look for, blah, blah, blah. And it's able to find it in the main system. So, taking a step back, realize what we just did. In our make install, we copy the library, the shared object library that has the major, minor, and patch, the 000 in this case. We copy that to user local lib. We create the 2 symlinks that need to be made as well in user local lib. Then we tell Linux where our directory is, just like everyone else does. And then we run ld-config. And all the ld-config does is it says, hey, I'm going to scan for everything, and it rebuilds the cache. Now, you might ask, well, hey, earlier, do you remember where I had to do this right here? Environment is equal to that. And we ran appdir. Do we still need that? And the answer is yes. Why? Because when I run /build apps test, what library is it loading? The answer is it's loading the one that's installed on the system. And it worked. But what if I'm working on this? I don't want to have to install it every time, right? I've got that my test watch thing. If I use the env is equal to env of ld library path is equal to, in this case it would be build, is it app or apps? I never remember. I think it's app. And then, oh, it's apps. Okay. If I run it like this, which is how my make file runs it, it overrides the global and it will use the local one, the one that I'm working on right then. So, permission denied. was going to say, because if I say make test, it works just fine. Oh, of course, because I didn't do the dash test. That's why. And how can we make sure of that? Well, if I say LDD, so LDD says, tell me what libraries you're loading. And when I'm looking for fish.io Tang, it looks in build apps, fish.io Tang. Whereas if I run LDD without setting the environment variable, there we go. So this is with the environment variable, and it looks in build apps. That's the one that we're working on. If I run it without it, it finds it in the main system. So it's working. That's what we need. Okay. So that's good. Let's make it so that I can do the pkg-config flags is it libs c flags, and so gtest is one, and these are the flags that get included when it's compiled. I want to do that, but with fish.io Tang. And it says, hey, I'm looking for a directory containing this file name. .pc is for package config. And maybe you need to add it and tell me where to find it and stuff like that. We can do that. So if we want to, and I have to double check my notes, for where I can put maybe this package config file. If I run package-config variable pc path, there we go. This shows us a list of paths. And I think, so of all these, user local lib, I don't want to put it in the x86 64 Linux GNU. User local lib package config, I don't think I want to put it there. I think I would rather put it here. User local share. Is that what I'm doing on a few others? Let me double check. Yes. So it's going to look here. This may not exist, but we're going to make sure that it does exist. So what we can do is so on the package config files one, let's see, at make directory of -p. So make it if it doesn't exist. If it does exist, it's not a problem. If it already exists, it will just go about fine. User local share package config. Now we're not going to put this in a subdirectory. It doesn't need to be, but it's because I don't want anything else to happen. And we need to copy a file that doesn't exist yet. We're about to make this file. Package config fish.io Tang.pc. We need to create this file. So on the right hand side, I'm going to say make directory of pkg package config, and yeah, and create a file. What did I call it? fish.io Tang.conf. There we go. Okay, so back up. On the left hand side, I can just create this, yeah, or edit it. There we go. Now this is just a text file, but it's a text file that kind of tells us where everything is. And so again, I'm looking at my notes for at least the names of what I need. Okay, so what needs to go in here? We need a name, colon, and we can say fish IO Tang. What is our description? This is a Tang scripting language parse and execution library. Sure. Okay. What version? 000 for right now. What's our URL? And I think, can I do that? Is that where it is? github.com/capital GHOTI-IO. Probably won't find it. For some reason, I have disconnected from the internet. Well, that's great. How about this? We'll come back to that. The URL. Now, so what you saw earlier, how I asked for pkg-config --libs and --c flags. This is where I say what I want to show up. So when you use libs, I want it to say fish.io-tang. And when you ask for c flags, I want it to be standard is equal to c plus 20 because we use some of those features. And -l is going to be where did we install it? User local lib fish IO. Yes. And you say, but Corey, we did all that work so that when you execute it, Linux can just find it. Why won't that work here? And the answer is because the loader, LD, I guess that's what it's for, loader. The loader will use all that information. The linker will not. It's a separate program, and it doesn't follow this. Anyway, we have to tell it where the program is. So that's what we're doing. We're saying, hey, it's going to be installed in user local lib fish IO. All right. Now, if I write that, and I think on the left-hand side, it says it doesn't know where any of this is. But if I now do sudo make install, I guess I need to finish what I started. So I'm copying that file, and where am I copying it to? I had a list of everything that I had planned for. Oh yeah. So I need that to go to user local share package config. Yep. All right, make install. It says it doesn't exist. pkg-config fish io dash tang. Oh, I said .conf. It needs to be .pc. I mean, I called it .conf. Okay. There we go. Move it to what was the .conf? Oh, that was for the Linux header thing. Okay, this needs to be .pc. Back up again. Run our sudo make install. We think that it's running. Okay. Oh wait. I can test it now. All I need to do is get to the pkg-config. There we go. And that's the command. So package config --libs, cflags, fishio tang, all of that. And that includes what you need to do for compiling it. Now, we're not going to use that internally. Why? Because we always want to use whatever we're working on locally. So this is to provide it when you run make install, it will install it so that well, yeah, what am I trying to say? It will install it so that anyone else can compile against this. Okay. So that's working now. The other thing I want to fix, I don't like it showing, oh, first of all, why is it showing ld-config? Because I didn't put an @ in front of it? Yep. And you know what? I'm just going to pipe its output to dev null, and this is saying take this, so this is saying put the standard out to dev null, and 2 is standard error, so we're saying redirect standard error to standard out, and redirect standard out to dev null. So now, if I say make install, it doesn't give me an error at all. Okay, I'll leave it there. So we got that. Okay, now the last thing that we need to do are the headers. Where should the headers go? That I've got to think about how I want this to behave. And I think the next episode is going to be restructuring how the headers work, maybe, so that I can, just put everything in the right place. Well, I'm trying to make this so that it works with all the other projects. And so if I go to, on my right-hand side, if I go to, that would be, what did I say earlier? User local include. There's nothing there. But this is one of the places that it should look for yeah, it should look okay. Let's do this. Let's say fish tang, and what needs to go in there. Oh, so there's all of this stuff. And what I don't want right now, I think I really only want to pound include Tang or Tang or Tang slash something. And that's going to take a little bit of refactoring. You know, let's do this, and I'll fix it in the next one. But for right now, so what's this going to look like? I need to make a directory for user local include fish IO. And now copy -r, well, not -r, let's say include, I can't type, include /star.hpp, and where are we going to put it? User local include fish IO. Anything else? I don't think so. So I'm making a directory user local include fish, copying all of my includes to that. Now, ultimately, it will be only tang.hpp will be in the main one, and then we'll have a tang slash and put everything else in there. But I don't have that 2 level set up here. So that's, like I said, that's going to have to be a separate video because, well, we're not quite an hour and a half, but I want to start wrapping this up. So, did I save this? I don't remember. All right, and if I go to user local include, there's now a fish, and now there's all the files. Okay. Oh, is that all the files I need? Isn't there... What? CD build. Yeah, I've got the generated. Huh. Is no Tang parser.hpp is there, and location.hh. Okay, so I'm going to have it also copy there we go, build generated and build generated dot hh. So the hpp and hh. There we go. So that should get everything. Rerun the make install. Okay. And now if I list everything in user local include fish.io, and we'll see that somewhere, yep, there's location.hh, probably behind my head. There you go. Location.hh. So it's getting it there. Shall we test this? You say, Corey, how on earth can we test it? I'm glad you asked. So I think we can probably compile the... So G++... And... Is it Tang? Vim source tang.cpp. Yeah, this is for the command line interpreter. So this is a standalone program. Okay. So if I should have planned this. G++ source/tang.cpp, and then I want to throw in pkg-config --flags --libs, no, -c flags -libs of fish.io -tang. If I do that and just say the O is, well, it'll default to a.out if it works. So, so it doesn't know where to find tang.hpp. Why? Because if I temporarily, this will not be permanent, but source tang.cpp, if I temporarily use this, because this is what someone in the real world hopefully would use. See if it works. Nope, not finding it. Why? I think I know. I'm looking to see, did I put something about this in my notes? And the answer is, no, I did not. Would my package config would I also need to tell it where did I put this? I'm not seeing it. Well, I did say I didn't have notes for it. Oh! I don't think I need this. This should have been that. It compiled. And we've got an a out, ./a out. And now it's waiting for input, so I can say A is equal to 1, B is equal to, oh, there should have had semicolon. B is equal to 2, and print A plus B. Oh, you're like, why didn't it work? Because I forgot to include my tags. Yeah. If I do that, now say A is equal to 1, B is equal to 2, print A plus B. There. And it prints out a 3. It works! I'm happy about this. Okay, so I need to undo one thing because normally compiling that, it's got to be compiled against the local stuff. So yeah, let me undo this change. But so remove a.out because it doesn't need to be there. And in this, so in the future, somebody, after they've run sudo make install, they can just pound include fishio/tang and it'll work. Yeah. Okay, but we don't need that in our program. So now get status, get diff. Those are all the changes. So let's see. We install the shared library, make a directory, copy the library, make 2 symlinks, and then we tell Linux where to find it. Fine. We install the headers, so we create a directory, so we can do fishio/whatever for the pound include, and now we copy all the header files and the generated header files, and lastly install the package-config files. Give me a sec. Yeah. So we make the package-config thing just to make sure it's there, and then we copy that package-config there, and then we run ld-config. So we're running it and not showing any of its output. So it's clean, and then we just say it's installed. And we now have a system that is installable. It took us a little while to get there, but it's there. Whoops. So we're going to add the package config directory, add the makefile changes, and make our commit as make library globally installable. Yeah. All right, so push that. It's pushed. Get tag 102. Is that the nomenclature that I use? Has my internet come back? It looks like it's back. Yeah, fishio. There we go. Tang. See, pool is there, but we're going to be combining them into one big project, I think. Let's see. It's already there. What do the tags look like? Yeah, episode. Okay. And this is 102. Our messages episode.102. Git push origin episode 102. All right, so that's pushed, and no lines of code changes. Well, lines of makefile. but no lines of code. So we're still sitting around 12,000. But you have no idea how happy I am about this. Because it's like, wow, it feels like it's real now. That is, we're creating something that is, even though it's version 000, something that behaves like the big boy programs, or something more official than just a little bitty side project. And take a lot of research, but hopefully it's helpful. There's a lot of little parts, getting the compile correct with the soname and getting the links, getting them in the right place, telling Linux where to look for it, telling Linux how to use the package config, or telling package config how to interact with your program. What was the other thing? Oh yeah, installing your headers in the right place, and a lot of parts. But we got it done without much stumbling around. Once again, thank you for joining me on the journey, and I hope the information's been beneficial, and also the explanation. I hope that is helpful. Otherwise, I wouldn't do it. There may only be one person on the planet that ever watches this and thinks, wow, I needed to know that information. But hey, if you're that one person, then hopefully it was helpful for you. Thank you, and as always, have a great day. Bye.